So we'll go over the review for Chapter 6. Number 1, we're looking for the greatest common factor. So looking for the greatest common factor of 15x to the 5th y to the 7th. Oops, x to the 5th y to the 7th. Z cubed 14 x squared y z to the 4th and 27 xy squared z and so we notice that the coefficients don't have any common factor other than 1. That we notice that all three, oops, miswrote that, it's xy squared, xy squared z, so we notice all three have a factor of x, all have a factor of x, a factor of y, and a factor of z, and so the greatest common factor of those is going to end up being just a nice, neat XYZ. We notice if we looked at the GCF of just the second and third, if we looked at 14x squared y z to the 4th and 27x xy squared z, we would have also gotten a factor of, well, no, actually, if we looked at the first and third, that's more interesting. We get the greatest common factor of 15x to the 5th y to the 7th z cubed. We notice we get a common factor of 3, a common factor of x, and a common factor of y squared. Oh, and a common factor of z. As you notice, obviously greatest common factor depends very much on which numbers, which terms we're looking at. Number 2, we had 14 times the quantity 2x minus 7, and 7 times the quantity 2x minus 7. So now we notice that they both have a factor of 2x minus 7, they both have a factor of 7. So the greatest common factor is going to end up being 7 times the quantity 2x minus 7. We could also have written it as 14x minus 49. Number 3, we're factoring out the greatest common factor. So we've got 57 x to the 5th y to the 7th plus 15 x squared y cubed. So the x squared y cubed is easy enough. We can pull that out, and that's going to leave behind 57 x cubed y to the 4th plus 15, just 15, because we notice the second term just has the x squared y cubed. But then we also notice we could pull out a 3. So we get 3 x squared y cubed times 19 x cubed y to the 4th plus 5. And then we notice 19 and 5 don't have any common factors. 4, we're looking at 19 times the quantity 3x plus 8 minus y times the quantity 3x plus 8. And so we notice that this one is kind of set up for us. We notice that the 19 and the y don't have anything in common, but the two terms have that 3x plus 8 in common. So we're going to get the quantity 19 minus y times the quantity 3x plus 8. 5, we're looking at factoring by grouping. So we got 9ab minus 3a plus 6b minus 2 We notice that the first two terms have a common factor of 3a, which leaves us with 3b minus 1. And then the second pair of terms has a common factor of 2, leaves behind 3b minus 1. And so we get the quantity 3a plus 2 times the quantity 3b minus 1. And number 6, we're going to get, we start with 7x cubed plus 14x squared. Subtract 6x, subtract 12. And so again, you're not going to get anything terribly complicated on the quiz. We can pull out a common factor of 7x squared, leaves behind x plus 2. Can pull out a common factor of negative 6, leaves behind x plus 2. And, whoops, so we wind up getting the quantity 7x squared minus 6 times the quantity x plus 2. And we're done. 7, we're looking at factoring trinomials. So if we have x squared plus 5x plus 4, we notice that we can factor 4 equals 1 times 4, 1 plus 4 equals 5, and so that's an easy one. We're going to get the quantity x plus 1 times the quantity x plus 4. And remember, the order doesn't matter. If we'd written that as x plus 4, the quantity x plus 4 times the quantity x plus 1, that's still correct. And then number 8, we have x squared plus 17x minus 18. Remember, negative 18 equals negative 1 times positive 18. Negative 1 plus 18 is 17. And so we know we're going to get x plus 18, x minus 1. Number 9, we have to work a little harder, because now we have 5x squared plus x minus 4. So we look at 5 times negative 4 is negative 20. So we need factors of negative 20 that add up to positive 1, but that's easy enough. We have no 5 plus negative 4 is positive 1. And so we're going to 5x squared plus 5x minus 4x minus 4. We get 5x times the quantity x plus 1 minus the 4 times the quantity x plus 1. And so we get the quantity 5x minus 4 times the quantity x plus 1. Easy enough. 10. We've got 3x squared minus 22x plus 7. So again, we have to work a little harder. We've got 3 times 7 is 21. And then we notice that 21 times 1 equals 21. 21 plus 1 is 22. So we can break this up as 3x squared minus 21x minus x plus 7. That gives us 3x times the quantity x minus 7 minus 1 times the quantity x minus 7. And that's going to give us the quantity 3x minus 1 times the quantity x minus 7. And we're done. If we were paranoid, we could verify. We can always check these by actually multiplying them out. We would get 3x squared minus 21x minus x plus 7, which is the 3x squared minus 22x plus 7 that we were looking for. 11, we're looking at difference of squares. So these are supposed to be pretty straightforward. We've got 49m squared minus 225. And so even if we don't recognize that 225 is a perfect square, the fact that we've got that 49m squared lets us know to check with our calculator. We check the square of 225, it'll turn out to be 15. And so we know we're going to get a nice, neat 7m minus 15 times the quantity 7m plus 15. Because we know a squared minus b squared is always going to be that quantity a minus b times that quantity a plus b. 12, same idea. We've got 36x squared minus 121, 36x squared and again, we should recognize 36 is 6 squared, and then 121, we either recognize that's 11 squared, or we take our calculator, take the square root of 121, and find out that it's 11. And so we get the quantity 6x minus 11 times the quantity 6x plus 11. So difference of squares questions are not supposed to be the hard questions. 13. We're solving using the zero property. So we've got x minus 6, the quantity x minus 6 times the quantity x minus 2 equals 0, so it's already set up for us. We know that x minus 6 equals 0, or x minus 2 equals 0, and so x equals 6 or 2. 14, we've got x minus 7, 2x minus 5. So we've got x times the quantity x minus 7 times the quantity 2x minus 5 equals 0. And so we know x equals 0, or x minus 7 equals 0, or 2x minus 5 equals 0. And so we start to work a little bit harder. X equals 0, so don't forget about the fact that x could be 0. X could be 7. Or if we add 5 to both sides, we get 2x equals 5, divide by 2. We could also have x equals 5 halves. So we could have x equals 0, or x equals 7, or x equals 5 halves. Number 15. You notice number 15 is just a little bit different. We've got 3 times the quantity x plus 9 times the quantity 7x minus 1. We note equal to 0. We notice that 3 doesn't actually do anything for us. We notice that 3 is never 0. So that doesn't give us any new solutions. So we're just looking at when will x plus 9 equals 0, when will 7x minus 1 equals 0, subtract 9, add 1. We wind up getting x equals negative 9, or 7x equals 1, can divide by 7, and so we're going to get x equals negative 9, or x equals 1/7. And so remember that the answers don't have to be integers, they don't even have to be rational numbers. For our purposes, we're pretty much always going to get rational numbers for our answers for Chapter 6. In general, the solutions to these don't have to be rational numbers. 16. We've got x squared minus 5x equals 0, so now we have to start factoring them ourselves. So we notice we've got x times the quantity x minus 5 equals 0. So x equals 0, or x minus 5 equals 0, and so we see x equals 0, or x equals 5. And we can always verify. If we plugged x equals 0 in, we get 0 squared minus 0 is 0. 5 squared minus 25 is also 0. 17, we've got 25x squared minus 49. So that's the difference of squares. We can say 5x minus 7 times the quantity 5x plus 7 equals 0. And you notice that if we set these up individually, we can say 5x minus 7 equals 0. Add 7. 5x equals 7, divide by 5. X equals 7/5, or if we prefer 1.4. And then we notice that we could go back and do the same thing for 5x plus 7, but we notice we're just going to wind up getting negative 1.4. It'll just be the opposite. And that's pretty much inherent to difference of squares, whether you have the positive version or the negative version. Number 18. Again, we're looking at now we're looking at a factorization left to ourselves. X squared minus 14x minus 15 equals 0. So we can factor that as x minus 15 times the quantity x plus 1 equals 0. And so, as usual, x minus 15 is 0, or x plus 1 is 0. And so x is 15 or negative 1. 19, we've got x squared plus x minus 12 equals 0. So again, pretty straightforward. We got x minus 4, x plus 4 times the quantity x minus 1 equals 0. X plus 4 equals 0, or x minus 1 equals 0. So x equals negative 4 or positive 1. 20. We've got the width of the rectangle is 5 feet less than the length. So we're saying W is L minus 5. And we're told that the area is 24 square feet. So we don't really need the units for our purposes. We're not getting anything really complicated. And so we know that the area also has to be width times length. So we notice that we're looking at when will L minus 5 times L equal 24. And so we have to look at when will L squared minus 5L equal 24. We're going to subtract 24 from both sides. We notice that L squared minus 5L minus 24 has to be 0. And so we're going to get negative 24 is equal to negative 8 times positive 5. Negative 8 times positive 3. We notice that negative 8 times positive 3 is negative 24, and negative 8 plus 3 is negative 5, and so we get L minus 8. The quantity L minus 8 times the quantity L plus 3 equals 0, and so we get L equals 8 or negative 3, but again, we discard that negative value. And so L is 8, the width has to be L minus 5, and so the width is 3. So we find out that the length is 8 feet, and the width is 3 feet.